Assalamualaikum everyone. Today our group would like to present about our MAT183 group project. So, this is the main characters of this group project. The main characters of this group project consists of Muhammad Reza Nasri, Muhammad Irfan, and Danish Mukri. For the next scene, I would like to introduce to guys about what is differentiation. So basically, differentiation is process of finding the derivative or rate of change of a function. In contrast to the abstract nature of the theory behind it, the practical technique of differentiation can be carried out by purely algebraic manipulations using three basic derivatives, four rules of operation, and a knowledge of how to manipulate functions. Are you guys curious about word differentiation? In differentiation, we will learn about how to use derivative to solve related rate. Next, we also gonna learn about how to use derivative to solve maximum and minimum problems. Last but not least, we also gonna learn about how to use the first and second derivative to analyze and sketch the graph of polynomial and rational function. We have choose related rates for our discussion in this group project. So guys, what it is? Related rates are rates of change associated with two or more related quantities that are changing over time. We apply related rates when problems arise in situations where the values of multiple variables are changing over time and their rates of change are related.
Next, we go to our problem statement. So our problem statement is the situation that is a group had committed in one festival. They had to face many challenges to reach their final destination. And one of the challenges is need to climb the cliff that had been blocked with big ice cube by using the ladder. But unfortunately, this challenge has their own requirement, which is the group of the men need to put the ladder where the ice of cubot has melting, which has the same level with the cliff. So the length and height of each ladder, the cubot had been given at the picture below.
Based on the question just now, an ice cube of cuba is melting at a constant rate of 0.5 meters cubed per minute. To find the surface area of the cuba in terms of x, we need to use the area equal to 4xy plus x squared. For the y, we can take from the height of the cuba, which is x plus 4. So we will substitute the y, which is x equal to x plus 4 into the equation. And then we can get 4x squared plus 16x plus x squared. And then we will get the area equation for the area is 5x squared plus 16x. For the question B, to find the volume of the cube of ice in the term of x, we need to find the equation for the volume, which is the base times height times length, which is the x times y. And then we can get the equation for the volume is equal to x squared plus y, x squared y. And for the y, we can take from the height, which is the x plus 4, and then we can substitute into the volume equation. And then we can get x squared times to the x plus 4. And then we can get the final equation, which is x cubed plus 4x squared. For the final question C, to find the rate of change of surface area if the length of the base is 6 meters. Step 1, we need to find the derivative area over the derivative volume. We have the area equation, which is 5x squared plus 16x. And then we will differentiate the equation to get the dA over dx, which is 10x plus 16. And then we have the volume equation, which is x cubed plus 4x squared. And then we will differentiate that to get the derivative volume equation, which is 3x squared plus 8x. So in order to get dA over dV, we go to the step 2, which is dA over dx times ds over dv. So the dA equation we can get from the differentiation that we got earlier, which is 10x plus 16. So for the dx over dv, we will inverse the dv over dx equation so that the dA over dx will be times by 1 over 3x squared plus 8x, which is the dv over dx inverse equation. And for the final result, we will get dA over dv equal to 10x plus 16 over 3x squared plus 8x. For the last step, to find the rate of change of the base, we need to use the equation that we got just now and sub in or times with the rate of change, which is negative 0.5. And then after that, when we get the equation, which is negative 5s minus 8 over 3x squared plus 8x, and then we will sub x equal to 6 and 6 meter into the equation. And then after we solve it, we will get negative 19 over 78 meters squared per minute.
So now we are at the end on this video. So for the last video, we can conclude that for this related rate, we can apply the chain rule when differentiating multiple variables in a related rate problem. Secondly, we can identify constant and variables in applied context. And third, we can figure out how fast the other one of the variables is changing. And the last one, the related rates come in handy way to solve the two related quantities.
And these are the two references that we use to do our works, where we rely the source to make our work. And that's all from our team. And remember, do not ever give up. The beginning is always the hardest. And that is the end of the series. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.